Good day, dear colleagues. The topic of my report is an approach to subject area ontology, visualization, system creating. Information and informatization technologies have covered almost all spheres of life in modern society. It is impossible to name at least one branch of human activity where their use would not be in demand. Ontologies are one of the best tools for formal presentation or knowledge about a particular subject area. Most often, the concept of ontology is expressed by defining the basic objects, individuals, attributes, concepts, and the relationship between them, but the analysis of complex concepts may require considerable effort and time. Visualization of ontologies is an important aspect of their practical use. Qualitative visualization provides experts with the understanding of ontology or its fragments, ontology comprehension, in solving various problems of knowledge engineering. The effectiveness of one approach to the visualization of the ontology significantly depends on the problem. One of the problems that requires the presentation of the ontology in the form of some visual image is its own understanding, as a result of which the user must understand the oral structure of the ontology, ignoring insignificant details. This task usually occurs when choosing it for use. In this case, the process of comprehension allows the user to decide whether in general, this ontology or its fragment is suitable for use in solving the problem. In the context of formal ontologies visualization, the problem of logical conclusions result visualization is also an important task. Its essence is to create a visual representation that can illustrate the derivation of logical statements to explain the result for derivation. Thanks to this idea, the developer can better understand the ontology as well as quickly find and correct problematic axioms that lead to semantic conflicts. The study showed that heterogeneous knowledge in intelligent information system is poorly formalized, which complicates the use of information system for the complex objects of operational management and processes and their evolution in terms of stuff. At the same time, the use of visual images contributes to a sharp increase in perception and allows you to quickly and effectively convey your thoughts and ideas. Numerous studies confirm that 90% of information a person perceives through sight, 70% of sensory receptors are in the eyes. About 50% of neurons in the human brain are involved in the processing of visual information. The authors, based on new scientific, technical, and philosophical methodological approaches, formulate a scientific hypothesis which states that information assembling systems, whatever imperfection they reach, are not sufficient in this context of realizing the possibilities of modern artificial intelligence systems. More heuristically powerful and information-intensive are information image structures. Given the same visualization, information image systems is associated with the future prospects for the development of computer technology, in particular the future of artificial intelligence. The analysis showed that there are two directions in the development of data visualization systems. The first is development of universal visualization tools. The second, specialization in all areas, including the creation of special graphics stations with the implementation of graphical algorithmic and software. If we consider the first approach, the existing methods of visualization are universal for different subject areas. Visualization of modeling results in physics, chemistry, and other applied areas. Typically, the application software system created on the basis are quite complex and cumbersome and do not contain tools and can fully satisfy the main specs of the data structure visualization. As for the second approach, it focuses on the narrow specialization of methods in which there are certain achievements that are embodied in different software. As can be seen from the analysis, this area is extremely important but not fully explored, given that the important and urgent task is to create a system of visualization of ontologies of the subject area, which would allow users to display the structure and adjust playback modes depending on the end-user requirements. The aim of the search is to create a subject area ontology visualization system an example of ontology models. The study will provide tools for the dynamic display of different types of ontographs and the accordance with the format criteria of visualization and reproduction of their properties for further use in the information systems for operational management of objects and the end user. To achieve this goal, it's necessary to solve the following main tasks: to analyze existing research and systems used in the field of ontology visualization, identify the main tasks that arise, build models of the visualization process, and implement the proposed approach using modern software. The results of the study solve the current scientific and practical problems of creating software for visualization of the ontology of the subject area, which will provide the simplest and most adaptive mechanism for displaying these ontologies for any structure and format. Traditionally, within the computer display, ontology is used as a mean of computer processing knowledge. However, with the growth of formalized knowledge accumulated on a media, there is a problem of the effective transfer for other systems and user experts. In this case, the cognitive properties of this structure come to the fore, which directly affect the simplicity and accuracy of the interpretation in order of obtaining concept. Given the analysis to possible ways of presenting ontologies were identified in the form of frames and the use of the simple knowledge organization system, SKOS. If we consider that frame representation, it can be represented as a visualized fragment of the ontology, which provides the means to display the structure for further transmission to the stakeholder. In this case, the frame contains two components: internal content, corresponds to the ontological context, and visual representation determines the features of the display to the end user. The visual representation itself, according to the founder of the theory of frames work, Aminsky suggests that processes of human thinking are based on the numerous data structures stored in the human memory, frames through which a person identifies visual images, frames of visual perception, understands words, semantic frames, judgments, actions, frames, scenarios, messages, story frames. Conceptually, according to Guarino, a frame consists of a set of units that are organized around a certain concept, action, process. The basic components of the frame are cognitive components that form an idea of typical events. In this case, any frame consists of field slots, terminals, the similarity between which is necessary to establish links between the information contained in them. Since there can be many slots in a single frame, that diversity must be hierarchically organized. As an example in poster 7, shows the taxonomy of that frame of the network rotary concept. The use of this data structure involves a high systematization of knowledge of increasing the number of structural relationship between vertical and horizontal elements. The SKOS system is a model of knowledge organization developed by a consortium of the World Wide Web, the main purpose of which is to use in the semantic web to facilitate the interaction of information resources through standardization if there are classification taxonomies. Unlike previous standards, the model is designed to make it easy as possible to bring other system of knowledges organization to it. Examples are the subject index of the Library of Congress and the multilingual thesaurus maintained by the European Union Publishing Office, Eurowork. SKOS identifies several semantic relations that can link to various concepts, such as SKOS, broader SKOS, narrowed, and SKOS related. In addition, SKOS supports the description of individual relationships. For example, SKOS narrowed as a more general relationship, SKOS narrowed transitive, which in turn refers to SKOS, semantic relation. An example of the SKOS ontology for the concept of network router is shown on poster 8. As it was shown, this subject area ontology visualization is a difficult stage in design process, given that its display is proposed to be carried out in fragments. Namely, first to visualize part of the ontological mapping fragment with the subsequent connection and use the ontology of the categorical level. In this case, the process of creating an ontology of the subject area is proposed to perform as a sequence of the following stages: formation of the list of concepts that are part of the ontological structure of subject area, ordering the list of concepts, creation of a glossary, display of the arcs between create concepts. Okay, next. Further research was aimed at automating this process, given the decision was made on the software implementation for the described approach. The analysis of the existing visualization system allowed to form the requirements to the designed system, which will provide opportunities for the correct display of the ontologies in accordance with the proposed criteria. The requirements are described using a mechanism of functions and delimitations of work for users and administrators. After defining the requirements, the system was designed using an object-oriented approach. A set of UML diagrams is constructed. In particular, the diagram of the use case is presented in poster 9. A studied subject area feature is a presence of different types of calculations and operations with data that need to be visualized, which requires simultaneous operation with the multiple user system. Given that, it was decided to implement in the form of a multifunctional website, which on the one hand will provide an independent access to the resource, and on the other will facilitate it is on different platforms. The design of the software architecture was carried out using an architectural style which is based on defining the basic elements of the system structure, component of subsystems, objects, and relationships between them using three-tied client-server architecture. This type of software architecture peculiarity is that it consists of three main parts: the client component of the program, which usually implements the graphical user interface and transmits requests to the application server using the types of data that it can process; a program execution server that implements business logic and sends requests to the third-tier server, such as an external API or a remote database server to retrieve additional data from it. Database server manages the database and it's responsible for the integrity and storage of data, as well as provides input-output operation when the client accesses information. The next stage of the study was the choice of implementing the software system means. The analysis of both the required functionality and the integrativity of the application contributed to the choice as a programming language, JavaScript, which uses the user's web browser in the execution environment. The main technology that we use is jQuery, HTML5, CSS3, Bootstrap 3. The Webpack library was used to build individual JavaScript modules, which combines all the software modules of the system and creates static resources that represents them. In poster 11 presents a diagram of the Webpack. In addition to Webpack, we used to grant task manager, write in JavaScript, and designed to automate a wide range of tasks such as source code complication, binary code collection, and system deployment. The combination of ground Webpack and Webpack Dev Server allowed implementing live server technology, which provides automatic start of the web server after each code update. The main model of the development system is a visualization unit based on D3.js library. The name D3 stands for Data-Driven Documents, which focuses on the use of JavaScript, FCG, and CSS, which provide flexible tools for creating ontological structures with animation elements and interoperability. Compared to pixel graphics, SVG has many advantages, namely XML-based, which makes the generated code easy to read and helps reduce the size of the generated images. These features have led to the fact that today this framework is the most popular for graphical data processing and creating various kinds of graphical interpretations. With the help of this framework, a frame model is built in the created prototype, which adapts to the user requirements. The described architecture formed the software implementation basis of the subject area ontology visualization system prototype, which was implemented in JavaScript. Poster 12 shows the main page of the website, which presents a visualized ontograph. As can be seen from the figure, the main window of the system consists of two parts. The left contains a hierarchical tree that displays the classes of ontograph, and the right, the main window in which the visualized ontograph is displayed. The format ontograph is presented in a tire parallel form, in which there are no relationships within the tire. This form of presentation fully meets the established criteria of reproduction and is easy to evaluate and further study. Separate function of the system is to search for the ontograph node by kterm, and the search result is displayed in enlarged form with toning. An example of the search of HTTP request is shown in poster 13. Currently, the system operates in the form of demonstration prototype with limited functionality, which will be expanded in accordance with the described functionality. As a result of the conducted research, the existing technologies and system of ontologies display on the given features which motivate the creation of a new web-oriented system of visualization are analyzed. The analysis of possible means of ontology representation in the form of frame models and the use of SKOS is carried out. The main stages of building an ontology of the subject area are described, and an example of visualization of the concept of network-computer attack is given. Further research was based on the creation of a project using an object-oriented approach and the use of UML language tools. The practical implementation of the system is based on the use of three-tiered client-server architecture using the JavaScript language. The result of the work is a prototype of an ontology visualization system that can be used to display a given structure and describes a specific subject area. Further research will be aimed at creating related software modules, their verification and coordination of operation.